So this is problem 2.6.8, actually a really nice problem where we're going to look at how far away 2 points are using latitude and longitude for anywhere on the planet. It's kind of a neat exercise. So just a really quick lesson in latitude and longitude. If you take a look at the globe here, this image, we can see that there's a prime meridian, which is 0 degrees of longitude. For longitude, every single line goes all the way around the Earth. There's a big chunk cut out here, but we can see 10 degrees, 20 degrees, 30 degrees, and that would be drawing a line from the center of the Earth, and if we measured out to this point and measured that angle, it would be 30 degrees. And it makes sense because we've cut out a quarter of the Earth, and the angle between this line and this line here is 90 degrees. So that angle here would be a 90-degree right angle. That's longitude. And actually, North America, we're over here at 122 or something like that, which is what Vancouver is. 90 would put you through the eastern part of the States in Canada. You can see it cuts right through Hudson's Bay. 0, again, the prime meridian cuts through England. If we take a look at latitude, you can see the lines actually get smaller as you get towards the north and the south poles. That's perfectly fine. That's the way they work. And these are a lot easier to understand. If we could sit at the center of the Earth and measure an angle with the horizon, that would tell us, that would give us that line. So 20 degrees is 20 degrees angled off of your horizon, again, from the center of the Earth. Hopefully that helps. You've probably seen this before. So what I'm going to do is start off by actually having a look at the class, the geolocation class. So nice, it's very well laid out. Everything in this is actually a great exercise at this point in the course. So the first thing that's set up are some variables that we have inside of the class. These are instance variables, of course. And we see we have public static final double radius, and this is the Earth's radius in miles as it tells us. And this is already preset, so that's a variable that we'll be using as what we would call a constant inside of the calculations. There's also a private double latitude and a private double longitude. And these, of course, will match, as we'll see down here in the constructor, with the parameters. So we've got the first parameter is the latitude, the second parameter is the longitude. So what we need to do inside of the program is whenever we create a new instance of the geolocation class, what we have to do is send 2 arguments that must exactly match. So we have to send a double that will represent the latitude, and also that'll be followed by a double that represents the longitude. Inside of our class, those values then, the parameter list, or the formal parameters as they're called, those will be assigned to our instance variables. And that's going to happen inside of the constructor here. So the constructor is a special method inside of the class. Okay, so what do we have here? Returns latitude, returns longitude. You know what? We could even remove this for now if we wanted to. I think the program actually works fine without it. So let's just get rid of that, just to simplify things. Those are important, don't get me wrong. There might be times we want to check on what the latitude is for a given object to return that value. But I don't think we need that in this case. Okay, so the last thing that we see, returns a string representation of this. So this is our toString method. And just to go through that again, if we try to print an object, what we'll get is we'll get a memory location. We'll get 3 things. We'll get the first, which will be what that object type is. Then we'll get an ampersand or an @ sign, and then that'll be followed by the last thing, which is the memory location. If we have a toString method, though, what will happen is it'll actually print out something that means something. It'll say latitude, followed by the latitude, in this case longitude, followed by longitude. You can put whatever you want in the toString, and then if you try to print an object in your main program, it'll print whatever you've set up in toString. It's actually a really nice way to print. If I remember, I'll come back and have a look at that after we get everything going. Down here we've got distance from, geolocation, and we don't need to understand this other than to look at something that's very confusing. So we've got a method, okay, and this method is distance from. And distance from is going to measure the distance from whichever object we use to call distance from and compare it to some other one, which we would also name as an argument when we call this method. If it's not making sense, I'm not surprised. That's okay, because I'll tell you, I struggled with this the first time that I went through the problem. And so we'll come back to this in a second. If you take a look at any of the other, in fact, let's go to the previous problem. if we have a look at any of the methods and we look at the arguments, what we'll see, or the parameter list, what we'll see in the parameters is almost always ints or maybe a string value. So these are much easier to kind of rectify. Here's a double down here. This is all making sense. That's what we would expect to see. But what we see in this problem that makes it an interesting problem is that the argument that we have to send into it, okay, to match the parameter, must be an object. So we actually send in an object of type geolocation, which is what this class is. So again, if you're confused here, that's all right, just hang in there. Let's start writing the program. And so what we have to do first of all is, well, I think I'm not sure if I've, there we go. We'll set up our input. So what we can do at this point is set up our next input. And if we do this, this will ask us for our first latitude, and then it's going to print it out. So let's just save this and run the code. Hopefully it works. And you notice it's just sitting there, so I can just type in, I'll do 1, 2, 3 for our latitude, and then it prints that out. It prints out the 0, of course, because we did initialize this as a double. Okay, just to make this a little bit neater to work with, what we're going to do in the line before our input, what we're going to do is go back to the assignment, and I'm just going to copy and paste from here. Make sure we get that colon as well, and we'll go like this. Throw that in quotes, put a space in there, and don't forget a semicolon on the end. The only reason we want to do this, we don't need that line, but it is a requirement, of course, for this program. But what that does is just make it look a lot more intuitive for the user. Otherwise, they have no idea what to enter. Okay, so let's go back to the assignment. And if you notice, they actually have the input at the end of the line, not the next line. I'm sure you recognize all we need to do to fix that is put print. Save that. We'll test it one more time. 1, 2, 3. Okay, we're good. Now we need 3 things here, so I'm going to copy and paste this a couple of times. 3 more, I should say. I'm going to change these so I don't forget. Latitude of the starting position. This is going to be longitude. Latitude of the ending position, right? Longitude of the ending position. And then we're going to go lat. This will be long 1. This will be lat 2. And this will be longitude 2. Okay, that should be everything we need to make this work, I think. And let's have a look. What do we have to actually put in here? We have to create an object. So let's do that. Geolocation, and we'll give it a name. Let's say start equals new geolocation. And I should probably capitalize that L or we're going to get an error. And for our arguments, we need to send in lat 1 followed by long 1. I'm going to copy and paste this line because we're going to do the same thing for the ending as well. Because remember what we have to do is send an object in to the geolocation class. So I'm just going to paste that line, but we're going to change this to end. New geolocation, and it's going to be lat 2, long 2. Okay. And you can notice I did a little mistake here. We don't need these system printouts. Okay, so one thing we don't want to do is have it print out the lines each time. So let's just comment these out. Hopefully simplify things a little bit. Let's run the code. Okay, in our last step now to get the distance, it's actually quite straightforward. All we need to do is call this final method down here, the distance from. And how we do that, well, it's actually it's not a hard thing to do at all. I'll go system.out.println, and we're going to go, we'll name an object, so we'll go start dot distance from, and then we'll put end. And so let's see if that works. We'll just click on check code here. And it didn't like something. We have to do the distance. Okay, so we just have to add the distance is. And let's do that. Plus, let's move this over. Distance from end plus space miles period. Okay, we'll save that. We'll run it again. Check the code. And it still doesn't like something. I spelled longitude wrong, didn't I? Save that and check the code. Oh, there we go, and everything worked. Okay, so what is going on here? Why does this work? Well, okay, I think it's straightforward to see that we created two objects here, and those objects, of course, when we create them, we have to make sure that we're following what the constructor requests, and I'll just move this over so there's room. And all the constructor wants is a latitude and a longitude. And we've done that, we've met that requirement. So let's go back to the getDistance method and see how it works. I've already mentioned how the parameter list looks different than any other method we've seen so far. If we go down here to the bottom, to the distance from method. It actually isn't all that different if you look closely. The first word, geolocation, is the type, and the second word, other, is the assigned variable name. In other words, it's just a variable. Nothing special. Whoops, there's our variable. The only difference with other variables we've seen is that instead of storing a single value, it references the object that invokes the method. So how does it work? Well, let's look at the method call. So here's the method call, and if it helps, we can actually divide this into two lines. So let's just do that. Okay, not sure if that simplifies things or not. Well, let's just make sure it works first. I better save this. Okay, we got to declare this, of course. Try that again. Okay, and it looks fine. Okay, so again, the idea was to try to simplify this thing a little bit by breaking this into two lines. And so what we're doing here is declaring distance as a double and assigning it to the output, or in other words, whatever is returned from the distance from method. So if we go to the distance from method, we can see that it returns the arc length times the radius. And the arc length, of course, is going to be a mathematical calculation of the distance between the 2 points based on the latitude and longitude. So what we're going to use is the start object. And you can see that down here. We're going to use the start object to invoke the distance from method, and we're going to send as an argument the end object. So let's go here and see how that looks. All right, so end is going to be other, or other is going to be end, is what I should say. And so each of the objects that we use, or that we've set up to invoke this method, both of those objects now have instance variables associated with them. And this can be a bit confusing. You notice how it just directly calls latitude and longitude. How can it do that? Those are instance variables. Well, it can do that because when we call this, we use the start object to call it. And so when it directly goes to latitude and longitude, those are the instance variables associated with the start object. Hopefully that clears things up. And down here what we're seeing is latitude and longitude again, but this time associated with the other object, other of course being end. Hopefully that makes things a little bit more clear. The rest of this is just some nice geometry, but remember, you don't have to understand how that works. You can have a look if you're interested in the math, but there's no requirement to know how that operates. And by the way, if we go back here again, we could actually switch start and end. So we could put end here and start here. And it shouldn't really make any difference. Let's see if I'm right. Yeah, there we go, of course. And the difference now is that start is going to be, it's going to be taken on by other, or other is going to be accessing the start object. Okay, hopefully that's clear. The last thing I want to do is take a look at the toString method. And what I'm going to do is start by commenting it out. So let's just go like this. I'll just throw a few more in here. Okay, so we have no toString at this point. We'll save this, and I'll go back to here, and I'm going to try to print the objects out. We'll just copy and paste this. Save it, and let's check the code. Actually, what I want to do is run the code, not check it. There we go. And you can see what it's doing here is it's printed out information that is not necessarily what we actually wanted to get out of this, and it's pointed to some memory location. Let's go back and uncomment the toString, see what happens. We'll save that back here. We'll run it one more time. And now what it does is it actually prints out what the toString has, whatever we put inside of here. So whatever I type is going to be printed out anytime that we try to print an object. Okay, so let's try this one more time. And there's our "this is cool" part, which of course we've said in the toString. And again, a toString, if you try to print an object, it will print whatever you've assigned inside of here. All right, hopefully this is good and clear. That's it. Over and out.